Okay, so BioC submitted. Let me do a little something here to hide floating meeting controls and minimize this little guy and say it's okay that you're recording me. Um, so BioC submitted as an R package. And why don't we just have a look at the R code? Vig2 data. So use the extract data facility in Elmer's doc to obtain summary information about textual content. Originally tailored to vignettes and Bioconductor, it is newly generalized to handle any PDF, HTML, or text and URL. These things are sort of becoming routine, that you can get something and throw it into an LLM and get some summary. And so there are some prompting going on here. We're going to pull down whatever we can get conveniently about the package, and then try to do some classification. Concise summary of the article using distinctive vocabulary, give a measure of coherence and its persuasiveness. These are just, very routine things now. And what comes out of a workflow, let's say, if we look in the vignettes, we can see what that's all about. The workflow here would be to apply over all the packages that are currently under review this function analyze repo vignette and produce some kind of a JSON result. And the result comes out here in packages classified.markdown. So in this case, we asked for 10 categories, and these are the categories that are provided. And if we look, let's say, at network analysis, we find that there are packages contributed. Where's the package name? Graphics, I didn't actually hold the package name out, but you can usually find it. Graph Experiment, Monarch R, etc. And then there are topics derived from the text, and ideally these would be BioC views terms, but or EDM terms. But I've done a little bit of analysis of the relationship between these terms, which were brought up ad lib, and what's in the EDM or BioC views, and there are, there's not a good correspondence. So this might be fuel for coming up with additional vocabulary items in BioC views or in EDM, and that is what we've got here. So that's trying to get a handle on the content of what's being submitted, and this is a summary of 96 packages that was available last week. So that's a very quick tour of this approach to trying to get a handle on content of what's coming into Bioconductor.
Vince,
Yeah.
Jacques has a hand raised. If
Okay,
you
go
want to.
ahead. I'm going to stop sharing so we can see each other. Okay, there we go.
Jack, I think you're muted.
All right. Sorry. Hi. So yeah, thank you. I have two questions regarding what you've just said. The first one is you browse the vignettes through using the HTML file, but you do have the Markdown file.
Yeah.
And
no, it can. I think the preference goes to R Markdown, and there are RNW vignettes that can be seen. There are
okay.
PDFs, etc., that could be acquired. For example, I don't think Limma has much of a markdown, but does have a PDF. So I'm trying to get the content that's relevant. It's not perfect. It needs more logic.
Yeah. And I had a second question, but then it slips away. Oh yes. Then the terms that you get back from the your LLM. Wouldn't you want to? So what's the idea of returning the terms? Is it to maybe generate new BioC or
yeah. So
use?
we have another system with prompts that drive the LLM towards the EDM vocabulary.
Yeah.
I decided not to use that now because that may have gotten out of date. And I thought it would be good just to see what these modern LLMs, this one was, Claude, very recent one, the Opus, I think it's Opus, it may be Sonnet, I don't know. But in any case, just to see what it comes up with a very, light prompt. And then see how close we are in our structured vocabularies. So it's very early, and the idea of driving it towards an ontology, I think, is a sound one, but the ontology had better be capable of that. And I think we're behind in both, in BioC views and in EDM. There are technologies and analytical approaches that just aren't recognized.
Yeah, right. So yeah, because I was thinking about how you could return a structured output rather than whatever the LLM wants to output. And then in that case, you could, rather pretty easily restrain the terms to whatever is in EDAM. But then you'd want to get maybe identify new areas that aren't covered. I see. Okay. All right, thank you.
Sure.
Is that still an irrelevant battle to sort of press things into predefined ontologies? Or is that, but I have heard recently many opinions that this is sort of a bit obsolete now with the LLMs.
Fair point. I think there's still a concern that hallucination can bring you to places where you don't want to go at all. So there's an MCP that's been developed by Sebastian Lobentanzer to, I don't know, try to take advantage of both types. One, the existence of a validated vocabulary, the other, the intelligence of the LLM.
Have you used any guardrails is probably the wrong word, but have you used any like of the markdown style controls to limit the vocabulary that Claude can bin these into, or you're just letting it free roam, basically? Okay.
No, the prompt is just, please give me some terms, essentially. Yeah. So that's out there. Go ahead.
I was going to ask, do you think it could, what would you think this would, how do you think this would behave if you gave it sort of the class files of a package? So if you said, evaluate these classes that this package provides and tell me where you think they belong in sort of a structured hierarchy.
Yeah. All I can, I haven't tried anything like that. Maybe others have in the classes group, the classes working group. What I can say is that as I've tried to use Claude Code to move forward in a couple of directions, I found that what it could do with S4, let's say, was pretty satisfactory, suggesting that there's a reasonable capability to analyze S4 classes. And I'll also eventually, I have an S7 implementation that I'll talk about in a bit, which has to do with ontologies in SQLite. That was my, I think, topic of annotation that I would do after Michael speaks. I guess he's still not here, eh? So my sense is that the high-end LLMs from Anthropic can do a lot in the world of classes, and therefore the type of analysis that you're asking for, I think, would not be that far-fetched. What else did I want to say here? Benchmarking and understanding, where the you fall off a cliff. I don't even know how to do that, but I think we would have to have experiments and values that we can appeal to. I see Robert Costello has a hand up.
Yeah, thanks, Vince. Regarding benchmarking, I was thinking whether you have tried to run the same workflow on a, let's say, carefully select selected set of packages that you think they are top of the line for their expectations of Bioconductor. See, like to calibrate whatever parameters you have, and then you can compare with the packages that are being submitted. How far off are they from those standards?
Yeah. Yeah, that would be a very opinionated type of exercise that I would not do lightly, but it's fair enough. And it's actually very feasible with this sort of thing to
Or
give a
just
nice.
take, the top downloaded packages, top whatever, top
Yeah,
10, top
yes,
15.
absolutely. Yeah.
But then the downside of this is most likely the model has been trained primarily on those, so it will be top of the shelf specifically for those, right? You'd have to go for a bit more niche packages, I guess. Also, I guess one comment I have, Vince, that I haven't brought up before is you keep saying that Claude, whatever you ask Claude, it does it pretty well. I don't have a Claude submission. I don't have the.
Yeah, I notice you're using Olama there,
institutions or
and
not.
the idea of a drop-in is actually supported here. So if you want whatever Elmer knows how to talk to, we can substitute the
But then
model.
have you tried the open source ones then?
I have not.
Yeah. So from the experience I have, the open source ones are quite far from whatever Claude could output.
Yeah. Well, I think that raises two questions. The first one is, do we see LLM utilization becoming routine in bioconductor software? I mean, Wolfgang likes to talk about things that are going obsolete, and it is very possible that, before long, our packages in Bioconductor, won't have the stature in people's work lives that they do now. I don't know. But right now, one could say, well, a developer would like to use Elmer and BTW and so forth in their package to do things that are related to the analysis of genomic data and to empower the user to take advantage of those things as well. Yeah. That would mean that we'd have to put on the build system, let's say, something like Olama, some kind of open source models that would allow that type of package to be tested. Have other people been thinking about that? And is that something we should explore?
Yes, that's something I've been giving some thoughts about in the past couple of weeks. And so you've seen my messages. It's something I'm trying to move forward with, and it comes from your suggestions from the BioC classes work group of trying to containerize trains of thoughts. So yeah, I'd be happy to maybe chat a bit more with you on that regard. Yeah, but I do think that, and also one thing is, I don't think that you'd need specifically for the GitHub submissions. What you could do is rely on Copilot rather than having a prompt sent to the build machine from Bioconductor. You can do all of it from Copilot directly in GitHub.
Copilot, yes, right. We should come back to that. Yeah. The second point I wanted to raise was, if you really needed a few months of support for using Anthropic or something like that, I think the NUM focus group should have some mechanisms for supplying some funding to support that type of work. So let's not forget about that. And the difference between the high-end models that I think a lot of people are going to be able to work with and the open models, I still do not have a good sense of that, but I think it can make a big difference. I see a hand up from Lori.
No, Nicholas.
Nick.
Oh,
yeah,
okay.
that's me. Sorry.
Nick's the leader on this Zoom, so
okay.
I'm somehow in charge of this. So I know that the NSF hosts some models on Jetstream 2.
Right.
So those are probably accessible given being able to gracefully handle connectivity from the build servers. But there are other options. I feel like Llama shouldn't be too terrible to run on the build servers. My understanding is that it's not massive. And at this point, most institutions, especially ones that have become sort of Microsoft shops, have institutional access to Copilot, although it's not something that has garnered a lot of goodwill for them, as far as I can tell. So, access to these models is becoming more and more baked into institutions, and I think that will continue, is my impression. That might be something we could leverage if that's something we want.
Right. I don't know how to use it yet. Alex Mahmoud has been doing quite a bit with it, so we have some access to expertise. I just sent another email to Mike Lawrence. I gather he has forgotten, and we don't hear. I think I can go on with another topic in the world of annotation, if people are interested.
We like annotation. I sent him one at the beginning, like right away, and I haven't gotten a reply yet. So I'm gonna take responsibility.
Well, it's one of those weird months with all the time changes and stuff. I'd bank 10 to 1 that he comes on at like 5 minutes to, going like, oh, it's not the next hour.
Goodness.
All right, let me set up my little material here, and then we will share screen again. Okay. So, and go to slideshow. Okay. So, don't worry. Things aren't going to change immediately, but I want to go through some of the things that developers may be relying on, users may be relying on, that I'd like to see go away. And when I show this picture here, what I'm trying to get at is that there are some very peculiar programming patterns that work because of some conventions that don't have a very strong rationale. Having different environments, and I'm talking about R environments, so very specialized structures adopted for performance with very good rationale 15 years ago, but not so necessary at this point. A lot of this is used by developers in ad hoc ways, and we don't want to thwart them, but we want to make progress. And maintaining this and doing things that are more modern may not work on our budget. So active bindings, performant environments, annotation DBI, they're very deep, and changing them is not going to be a very straightforward task. Go.db has its own API for the gene ontology, and you can see keys or L keys or select being used as different ways of getting information about the ontology. And it all lives in annotation DBI. All the infrastructure is there, but it has a method called select that's in conflict with, whatever you use SQL for and what you use select for in the tidyverse. The SQLite schemas that are used by annotation DBI are complicated. They have special keys to allow some cross-database operations. The developers, the creators of this, very creative and intense people, have left the project long ago. And the annotation pipeline that they put together in order to do this for Go and org.hs and org.mm and many other things, all the Affymetrix chips, for example, the pipeline that does all of those things is old and fragile. And technology for this type of data has moved on. So I want to see if we can do things a little differently. And the phrase "get out of the way," I think I would thank Wolfgang for using it in one of our tab meetings. If I can do something that's more comprehensive but simpler, I should do that. And it turns out that we can deal with all ontologies in a very, I think, effective way, and don't have any special catering for gene ontology versus cell ontology, et cetera. So if you can do this for all of them, just do it. And likewise, if you can get standard interfaces to genomic annotation for all model organisms, let's say all those recognized by NCBI, just do that and don't pick and choose particular ones. Once you have come with this principle, then you can come up with a few basic use cases and see what happens in the user and developer world and figure out what needs to be tuned up. And so my hope is we can gradually phase out approaches that are actually obsolete. We'll do annotation DBI for 3.23. Dependent code will continue to work. It might even work in 3.24, et cetera. But I'm not going to run the pipeline again to update these things. If you want the latest annotation, you'll have to come to a new approach. And so I have a package now in review called OntoProc 2. This uses S7. Why? Well, you're going to work with SQLite. That's because of work that's been done by the ontology community in something called Semantic SQL. And they have SQL databases for 150 open biomedical ontologies. So we want to use those. It includes cell ontology, gene ontology, disease ontology, EFO, experimental factor ontology, and so on. These are things that are used all over the place, and they can all be handled in a uniform way through this approach. And there's an S7 report that's produced. It tells you how many different things are labeled. This entailed edges is an important concept. They pre-compute all of the statements that are consistent with the base axioms of the ontology, and they give them to you in SQLite. So that's all very valuable. And I showed you what? Cell ontology. Gene ontology has 9 million entailed edges, they call it, and 88,000 terms. So if you use this semantic SQL connect with the ontology Go, you get this object. And then we can use different ontologies together. So for example, Uberon has annotation for the anatomy. Looking for forebrain, I need its tag. Looking for a relation. Now I want to use formal relation. So I want to find genes or cells, let's say, cells that live in the forebrain. So I need to use an ontology for that. There is this term has soma location, which is part of the relational ontology, which can be used to go and find those things that are located in given parts of the anatomy. Finally, I want to find which neurons are in the forebrain, and I need to know the cell ontology tag for that. Once I do those things, I can find all of the neuron types that are found in the forebrain by running a simple query. I guess I didn't put it here. It's in the vignette for OntoProc 2. I wasn't planning on having a lot of time. Any questions about this? Maybe worth noting that Sean Davis has an MCP, a Model Context Protocol server for ontologies, leveraging the ontology lookup service. So that's another place where you can get all the ontologies and interact with them programmatically in various ways. Laurent Gatteau also has ROLS, which is a nice package that allows you to communicate with all those ontologies. So yeah, this is another one, but I am trying to have more use cases worked out fully for things that are relevant, like finding cells in anatomical places, doing gene set enrichment, and so forth, using something that somebody else is maintaining. That's the representations of the ontologies. Then there's TXDB. I put a bit of this in Zulip. the package is called LookPark because this is very preliminary. I don't know whether anybody's going to buy into this. Mike Love had a look at it and was not dismayed or put off by it. But the basic idea is that TXDB also relies on SQLite and somewhat intricate schemas coming from Annotation DBI. And it's possible, I think, to do this with less of a footprint and to be more, I don't know, to present more. When we use TXDB and we ask for the genes of this particular object, we just get gene IDs and ranges. But we can do better with the gen code representation in this GTF parquet, and we not only get the identifiers and the what do you call it, addresses, but we also get various metadata about the genes that comes with gen code and which gen code users have come to depend on. Now, Bioconductor's relationship to gen code has been mediated in the past through Leo, who had a way of getting them into Annotation Hub. That's fine, but my approach here is to have a builder of these parquet-based entities that can be deployed not only for gen code, but also for any of the NCBI model organisms. Same code base. So I think that's probably it. Getting out of the way means reducing the complexity of the interfaces to the content. I can replace org.hs and all the other things for all model organisms. Parquet can reduce the package size. This is a costly operation, right? Managing annotation for other people. We have a number of groups that do this. For example, Johannes Reiner works on the ensemble. They're changing their API. He's concerned that much of his code base may not be usable under the new API. We don't know. Another thing I don't know much about, I mean, I can search through the code base to see what developers are actually doing with annotation. It turns out it's often complicated, and I don't have a comprehensive view of it, but we'd like to, make sure that we have sustainable APIs for getting the annotation that you need. What users are doing down the road, also, we do not know. And this concept of a forge, so that you can make your own curated resource image or package, is valuable. We have Annotation Forge. We have a few others. And I have an example of this for gene ontology. So if you needed a new gene ontology representation based on something which we haven't gotten to yet, you could use this BioC Go Prep package to build your own. And finally, our action items are, I would like to replace Annotation DBI and the pipeline, train developers to use these resources, and then users to use them, and then measure the effects of this change. So that is that. Hand up.
So that was really nice. Thank you for that introduction to that work. I've spent a long time thinking about accessing and working smartly with the NCBI GFF files. So I'm glad to see other people think about that in some amount of depth. Would you say managing the model organisms, I assume you are talking about the reference, right?
Well, there's reference genomes,
Yeah.
which are managed in NCBI. There's also gene annotation. And it turns out that there's the nomenclature of genes for NCBI for all model organisms that they recognize. They're well over 100. Then gene 2X. And what is X? X can be PubMed, it can be Ensemble, it can be gene ontology, etc. They do that. They curate those tables. Those tables should just be made available to Bioconductor users so they can query them, join them, etc. The Annotation DBI does not do that, does not present them in that way. They're very heavily curated turned into environments and so forth.
So, my experience dealing with those, so basically, my understanding is that there's still some reference genomes that are hand annotated, but for the most part, annotations are coming from PGAP and UGAP, even for things that are, you know, pretty close to everyone's heart, but you know, like human and E. coli, to the best of my knowledge, are the two major ones that are still hand annotated as opposed to computation or derived from the NCBI's in-house pipelines. And there are still differences between those hand annotations and the computationally generated ones. Is that a worry? Is that something that we should be thinking about?
I think we should definitely be thinking about it. It's not a field that I'm that familiar with. I've sort of just followed the way in which we've harvested the NCBI materials. But you're talking about something which I am actually not at all familiar with.
Okay, sorry. I've done too much of this over time.
That's
I'll
absolutely
see the
fine.
floor to
Well,
Robert. Yeah.
please keep an eye on this. Yes. Go ahead, Robert.
Yeah, regarding Autoproc 2, so if I understood correctly, what you showed, it's a way to uniformly parse ontologies, I don't know, for instance, OBO files of any kind and so on. But so this is a two-component infrastructure, right? We have in one hand the ontologies, and the other hand you have the annotations for the ontology. So what gene is annotated to what GO term, and those come from different sources depending on the organism, right? So
Yes.
the GIST people annotate GIST genes and so on. So what is the proposal for harvesting all those annotations of genes to ontologies?
Okay, let me be very clear. We're not parsing oboe anymore. We're letting the oboe people transform the oboes into SQLite. Okay, so they have done all kinds of inferences to link terms across concepts within the ontologies. And the ontologies are just vocabularies. They're not annotation to genes. So the annotations from genes can come from anywhere. And what I'm describing is simply the NCBI-based gene to go, which is a very large text file that NCBI updates on a very regular basis. Now, where it gets its information from about the function of a gene, I do not have immediate knowledge of, but there's documentation in the NCBI FTP site about the provenance. Does that answer your question?
Yeah. So then what you mean is that the annotations of genes to ontologies, they are there is a centralized resource at the NCBI for this.
That's
and
what
we can take advantage of that.
Right.
Oh, that sounds good. Okay.
Yeah. Now at EBI, there may be something different. A gene ontology annotation, GOA, is something that I have heard of. I have not really ever got my head around it. And NCBI may indeed be capturing that and presenting it back. So, tracing through this process is definitely something that can be done, but I have not done.
So maybe to clarify that process a little, I don't exactly know what NCBI's association with the term you just said, and I have forgotten already. But so PGAP specifically will basically pulls from a series of evidence streams, and UGAP does as well, but it's much more complicated because the base gene calls have to come from a very different source. So PGAP has a set of databases that have UniProt and NCBI specific accessions in them that it knows how to then assign in the GFF file and the other annotation files that it does create. And so as far as NCBI and EBI resources are out of line, I think it still does provide accessions in both directions, but my understanding is that they're fairly well aligned. The question that I actually had was, so these are being provided as SQLite files. Does this mean that you have to pull a static version of what Obo is providing and update that on your own? Is that what's happening in that regard?
At the moment, yes. I mean, this is not part of the ecosystem yet, but basically the way it works now is, yes, our friends over at Obo produce all these SQLite representations of the ontologies. The package that I've described, ontoproc2, will, when queried, go out there and take the SQLite and put it in your BioC file cache. So then you have the ability to have multiple versions, if necessary, of a given ontology, depending on how you manage your cache. The versioning issue I have not gotten heavily involved with yet. These can be large files, hundreds of megabytes, so one wouldn't want to have too many, potentially. And then the version can be quite significant as to what you are computing. So you definitely want that to be a first-class bit of metadata about the ontologies.
Do you know the rate at which they change? I mean, I know that some NCBI, some of their big metadata files change weekly or daily, depending on the data that they ingest.
Yeah,
Is that the same here?
that's right. So
Okay.
the gene to go, I think, could be updated very, very frequently. So that's going to be a job that Bioconductor would actually do from version to version. I mean, that's one of the reasons we have this 6-month version cycle. It puts the brakes on in a certain sense to say you have a stable annotation system for at least 6 months and potentially longer, depending on how you want to manage your versions. So I would be following that tradition, that the way in which we build this Parquet representation of the NCBI reference information would be done at a cadence.
And
So is
then
there
I
anyone
guess
here who's so enamored of go.db or org.hs that they do not want to see an evolution away from those approaches? I could put it another way. I did work very hard at trying to make a pin compatible representation of org.hs.eg.db that was based on Parquet instead of SQLite and satisfied the select and had all the different environments. And I gave up. It can be done, but it just requires too much time and effort to sort of build the thing that has the same API, very diffuse as it is, out of new material. So if people really need it, I think we can do it. We might want to cut down the number of features that are preserved as we go through this evolution. But I'm not trying to force people away from familiar and effective programming patterns. Yeah, Nick.
sorry, I just have what's feel like low level questions. Is there a Parquet driver for DBI?
Uh, and that's a kind of question that I'm just not technically astute enough to answer. The way I use Parquet is through Arrow. It can also be used through DuckDB. I don't know that the DBI package directly confronts Parquet type serializations, but yeah, I'm not even sure it makes that much sense since it's not really SQL, but many of the tidyverse operations can be carried out through Arrow's interface to Parquet.
I had thought that DBI was not SQL alone. Is that incorrect?
No, I think you're right. I mean, DBI, what can I say? DBI exec query, right? That's a fundamental tool in there. It's expecting you to give it a SQL query. Can you have other things in there? Yes. So you can have an arrow, a Parquet table. Yeah. I mean, maybe I should just do this. We're doing a developer meeting, right? We either somebody else shares screen or I share screen, and we just do it. All right. So we'll share screen. We'll get a code thing going in my terminal, and we'll see what we're talking about. So who knows what that's all about? How does my screen look? Big enough? Font is good enough? Yes?
Looks good. Yeah.
Yep.
All right, let's see how some of this works, because I don't really remember. Library onto proc 2, let's say. No, let's do library look park. I don't even know how many things I'm dealing with here. Okay, so this is a thing that's dealing with NCBI type annotation. And let's see if we can remember something. Example, GTF Parquet. Let's do that. Parquet. Okay, so what's going on here? There's a system file. Let's look at that. And let's do a dir of that. Full equals true. Okay, so there's a bunch of Parquet files here. Now, let's use dplyr and say, let's say TBL. What do I need to do? CDS equals, I need to get arrow also, I think. Okay, and now I say DS equals open data set, and I'm going to take this string here, right? So DS is like that. Then I say TBL. DS looks like that. Can I do TBL? DS? I don't think so. No. But I can say DS select transcript ID, gene ID, right? So that's like that. And then we do collect head. And now I'm seeing a table. I don't know if that's answering your question. I think there are other ways of working with this type of stuff. Maybe not. Dplyr, DBI. I'm sorry. I don't have a good sense of this right now. But does this help a little bit working with the Parquet? Or is this
Yeah,
all
that was really illuminating. I guess the position I'm coming from is I've worked not a lot, but I guess a little with doing with both SQLite and SQL databases. And there was a point where DBI got taken over by I think some of the Posit folks, and that might have still been our studio at the time. And it changed fairly dramatically. So like what used to be built-in SQLite drivers, I think were pulled out into a specific R SQLite package. And I didn't know if DBI was trying to provide other database flavors outside of sort of the SQL family.
Oh, yes. Let me just try. This is something I keep forgetting. Again, so here we are with a SQLite table. This is part of OntoProc 2. And I can now issue SQL queries against this table. it's a SQLite database, so DBI should also work with it, right? So DBI, library DBI, if I say DB connect, I'd have to give the path to the database, right? So DB connect SQLite, right? And then you give it this thing, then you'll get a list of all of those tables with DB. Right? I don't have DBI yet. That library R SQLite. Right? So that does that. And now that's my connection, right? DB list tables con. So this is just, a very primitive way of dealing with this thing that I've tried to mediate through the methods in Ontoproc 2. So I'm not sure that DBI has been I don't know, broken up in an unfavorable way. But if there are things that you think are missing now, then we should try and see how to recover them. Always good to do live demos. You get a sense of what you do and do not actually understand. All right, 12:56, 55. I've got to go to another meeting. Didn't mean to take the whole hour.
Before you head out, can you give us some perspective on Helena's question?
I'm sorry, I didn't see it. You got to speak up.
It's in the chat. Sorry.
Order for certain operations. Probably. So you're thinking that the underlying serialization may be structured in ways that are
Yes.
better or worse for different routine operations. Yeah. So benchmarking and figuring out, what the appropriate, maybe having multiple serializations for different use cases. Not a place where I'm at all expert, but it seems we could use some data on that.
I mean, if it was just SQL, it would be a question of having the right key to make it as fast as possible. I don't know if the files are even big enough for that to really be a concern, though.
Well, if you do indexing in SQLite, you start blowing these things up
Yeah.
in terms of size, but it can be very effective.
Yeah.
That's too bad Mike Lawrence is not here because he knows a lot about columnar databases, and I'm sure he would give us a lot of useful insights. So hopefully next time he'll come.
I hope so. I'm gonna take responsibility for this. I did not really think about trying to remind people that timings were going to change. So,
what timings changed?
Like daylight savings and stuff. So
Yeah.
some people's calendars are off by like an hour, depending.
Yeah,
That
we
was
are
a long time ago.
Well, we're in the frame where you guys have gone to daylight savings, but Europe hasn't yet, I think.
Oh, I
So-
see. Okay.
Or maybe that just switched. I don't remember.
All right. Well, thanks, everybody. I hope you enjoyed that. And any questions or comments are very welcome. I'm going to hit the road. Thank you.
Thanks.
Thanks, Vince.
Thank you.